Hello class, these are the two examples about finding the angle between two intersecting lines. So let's get on with it. So in here you're given line 1 and line 2, which are represented by their respective equations. And I have a Cartesian plane because I want to sketch these two lines and see more or less in what quadrant they intersect, because they could be intersecting in this quadrant. Okay, they can be, like, for example, when I draw them, they can be intersecting right here, you see, or maybe they can be intersecting over here, you see. So I need to sketch them. I need to sketch those two lines and see their respective directions, more or less. Okay, so how do I do that first? We do the following. The first thing that you can do is get the intercepts of these two lines with the x-axis. Okay, the points of intersection of these two lines, of each of these two lines, with the x-axis. For example, for the first line, you have this. And how do you find the x-intercept? Well, remember that for that, you have to make the y-coordinate equal to 0, and you end up with this equation. And after you solve this equation, you will get minus 5 over 2. So that's the x-intercept of my line 1, which is, in decimals, it's minus 2.5. And I'm going to locate that point in here. Minus 2.5 goes to the left of the y-axis. I'm going to put it right there. You don't have to make a scale, okay? You don't have to. It's just a rough sketch. So that's that. And you do the same for the other line, okay? You have this line, y equals minus x minus 1, and find the x-intercept by making the y equal to 0. And then we have this, and then when you solve it, you will get minus 1. Yes. So x equals minus 1 is the x-intercept of the line 2, and it should be more or less over here. This is minus 2.5, this number, and this is minus 1, which is this number. And if you don't wanna get confused, you can label them. Like, you can label this as 0.1 and 0.2 in order to say that this is the point, the x-intercept of the line 1, and 0.2 is the x-intercept of the line 2. Okay, fine. Now, what's next? We have to find the point of intersection between those two lines. Okay? What is the point of intersection? How do you find that? You're gonna take both equations for both lines, and you're gonna solve this system of equations. Okay? And you did this in first semester, and I think we have already done this also, so it should be clear for you how to do that. So in this case, what I can do is, if this is equal to y and this is also equal to y, I can write down this equation, and then when I solve it, I'm gonna get that x equals minus 2. So this is, if I represent by this symbol the point of intersection, then I already know that its x coordinate is going to be minus 2, comma. And how do I find y? Well, now that I have this value for x, I go back in any of these of my previous two equations, and I plug this value in any, either here or here, and I get the value of y. So when I put it there, I'm gonna get 1. Make sure of that. So this is the point of intersection, and that point of intersection lays in this second quadrant, right? Because it's going to be minus 2, which is roughly over here, and then comma 1. So I'm going to exaggerate my sketch. Maybe it should be a little downwards, a little below, but I'm gonna do it here because I want my triangle to look big. So this is the point of intersection. I'm not gonna label it because I don't want to write too much stuff. There is no, if I don't label it, nothing happens because I know that this is the point of intersection between the two lines. Okay, and now I have everything to sketch my two lines. The line 1 goes through the point 1 and through the point of intersection also. So it should be looking like this, more or less. And my let's label it line 1. And the line 2 is going through point 2 and the point of intersection. There you go. There you go, guys. So this is the first thing you want to do. You want to find the sketch for your two lines. Okay, so in what quadrant are they intersecting? In this case, it was the second quadrant, and that's the first thing you have to do. Now that we're done with this, um, well, let's keep these values over here somewhere. I don't want to lose them. P1 is minus 2.5 comma 0. P2 is minus 1 comma 0, and the point of intersection is going to be minus 2 comma 1. And that's all I want to keep from all of this thing. I don't need the rest. I just need the results, so to speak. And look, guys, the reason I'm not late, the reason, for example, that I'm not writing the coordinates here in point 1, point 2, or in point of intersection is that I want to keep my diagram as clean as possible. When you introduce too many symbols in your diagrams, they start to look very contaminated, so to speak, and it's just gonna confuse you. So the cleaner you can keep your diagrams, the better. The more well organized, etc., that's the better. Okay, there is this. Okay, so we have this now. And in broad terms, in very general terms, what do we have to do in order to find the angle between line 1 and line 2? First, which angle am I looking for? For example, if you look at line 1 and line 2, they cross at this point, one more time, and they make two angles. They make this angle, which I can call theta 1, and they make this other angle, which I can call theta 2. So which one is the smallest? I do not know yet. Okay, with just the sketch, I cannot know which one it is. I have to calculate them and find which one is the smallest, and that's going to be the angle between L1 and L2. Why do I say that with the sketch is not enough? Because of the same thing I've been telling you. A sketch is just a visual, it's just a visual aid. It's not a method of reasoning. Okay, it's a visual aid. It can inspire you to do things well, etc., or to help your mind deal with the problem, but it's not a method of reasoning. So even if you look that two lines intersect in this way, and you can see that this angle looks smaller than this one, that's not a proper way to reason. We have to find those two angles and then decide for which one is the smallest, basically. Okay, and how do we do that? What you have to do is find all these, when these two lines intersect, they're always going to form this type of triangle, either above the x-axis and resting on top of the x-axis, or the other way around. It's gonna look something like this. For example, like so. You see, if you have other two lines, this one and this one, in this case, if you notice, the triangle is being formed below the x-axis, but also resting. You can see that this side is resting on the x-axis. Okay, so it's always gonna be either this case or that case. For example, you can also have this. You see, the triangle is being formed here, or if you have the two lines here, the triangle is forming here. So you see, those are all the possible cases. Okay, And the general way to solve this problem, like I told you, is finding all these three angles. This angle, let me call it A1. This other angle, let me call it, well, let me call this angle first A2 because that's the angle of the line 2. Let me call this angle A3. And this other angle right here is also theta 1 because they are separated by the vertex. Remember, angles separated by vertices are equal. When you have this angle is equal to this angle, and this angle is equal to this angle. That's a mathematical fact. Okay, how do we find those three angles? Theta 1, angle 1, and angle 3, and angle 2. Okay, how do I find all of this stuff? I start to reason. I start to reason. If it helps you, you can actually separate this diagram and make it much larger. That's always a good technique. You know, separate what you have to, like zoom, make a zoom. So you have this, there you go. And what I'm gonna do is this one. Look, well, we have the 2 points, the 3 points, I'm sorry. And I'm gonna divide this triangle in this way. I'm gonna drop a perpendicular in this way, so that I get this right triangle and this other right triangle. Okay, what for? Why did I do that? Because of the following. I can help myself finding these angles by the slopes of the two lines. If I know the slopes of these two lines, I can find all of these angles. For example, what is the slope of the first line? The slope of the first line, let's call it M1, and according to its equation, that's going to be 2. And the slope of the second line will be -1 according to the equation. And what does that mean? It means the following. Well, let me erase this. I need to erase it. What does that mean? It means this. Remember, what is the slope? A way to look at that is rise over run. When you have a line like so, and you locate any point, it doesn't matter, any point and any other point, point 1, point 2, the slope of this line is defined as the following. When you go from point 1 to point 2, you have a run in the x-axis, and the run always goes from left to right. We always consider the run to be from left to right, and the rise, which in this case is positive. You see, this is your rise, this is your run, and the slope is given by that ratio, rise over run. Okay, when you have this other case, a line going like downwards, like in this case, it's the same idea. You get this point, point 1, and then point 2, and then going from point 1 to point 2, you're having this run in that direction, always from left to right. This is the run, and the rise is going downwards, because going from point 1 to point 2, you actually went downwards. And that's why in this case, when the line has this direction, the slopes are negative because the rises are negative. Rise over run, and in this case it's going to be negative. But it works in the same way. It's rise over run. That's the whole idea. Okay, so how can I help myself with by knowing these two slopes? How can I find all these angles in this triangle? Well, you have to reason in the following way. If you notice this point right here, point 1, which is the same as this, has coordinates -2.5, comma 0. This other point has coordinates -2, comma 1, and this other point has coordinates -1, comma 0. So, for example, this is the segment of line 1, which is this one, right? And basically what I know is that its slope is 2, okay? And what that means is that when I calculate, well, if this is its rise, you see, this is the rise. When you go from this point to this point, this is line 1, remember? When you go from this point to this point, this is the rise and this is the run. This is the rise, this is the run. So basically, what is the rise? We're going from this line towards this point, and how much is that height? How much is this rise? Who can tell me? You go from 0 to 1. So this rise is 1. Can you see? This rise is 1. And the run, which is this, how much is that? You go from minus 2.5 to minus 2. So the run is 0.5 units only. Can you see what I'm doing? In the y-axis, we went from 0 to 1, and that's why the rise is 1. And in the x-axis, we went from minus 2.5 to minus 2, which is a total of 0.5 units. So we have these guys. We have that this side of this triangle is 1, this other side is 0.5, and we know that this is a right triangle because of this, because this is a perpendicular to the x-axis. Okay, and that can that help me? Yes, because now I can calculate this angle, which I called a moment ago, I call it A1. Okay, A1. Now I can calculate this angle. How? With any trigonometric function. It doesn't matter. I told you before that you could use only sine. I'm sorry, only tangent. But in theory, you can use other functions. But let's keep using tangent. So I do this. Tangent of the angle 1 is equal to, by definition, is opposite cathetas. So I'm going to write opposite cathetas over the adjacent cathetas, or the adjacent side. And if I look at the angle 1, what is its opposite cathetas? It's going to be 1. That's the measure of that cathetas. And the adjacent cathetas, which is this one, I just write it down, 0.5. So that's it, guys. Now all you have to do is this. Tangent of A1 is equal to this over this, which is 2. And finally, if you want to know this angle, and you know that the tangent of this angle is 2, then you take the inverse tangent of 2, and that's how you find A1. So take your calculator and get me that angle. Tangent of 2. I'm getting 63.43. 63.43 degrees. And that's just an approximation, okay? It's not an equal. It should not be an equal sign. 63.43. So now I have found this angle. I already have it. Let's put it right here. Angle 1 is equal to 63.43 degrees. Well, approximately. You see how simple it is to make mistakes? Approximately 63.43 degrees. Okay. You see, so that's how it works. You're gonna make use of this little triangle. You're gonna divide it in by a perpendicular in here, and you're gonna use the slope, okay, of each of these lines in this way. Okay, now I have to do something similar for this other triangle in order to find this little angle here. If you remember, I called it angle 3 a moment ago. You can call it whatever you want. It doesn't matter. The names are not important as long as you are consistent. And I want to find the angle 3. Okay, if I want to use a similar method to find, as I did for finding the angle 1, all I can do is this. This triangle is part of a right triangle, which is this one. I already have its opposite cathetus, and all I need to know now is its adjacent cathetus, which is this little part here. This is 0.5. And now how much is this? Okay, I look at my 2 points. Look at this point. Look at this point. Look at their x coordinates. We go from the x coordinate goes from -2 to -1. So how much is this in units? It's gonna be 1. You see? Okay, and that's it, guys. That's it. Now, if I have these two catheti, now I can calculate the angle 3. I use the same idea. I write the tangent of the angle 3, its opposite cathetus over adjacent cathetus. Okay, and we continue. Tangent of the angle 3. What is the opposite cathetus? 1. What is the adjacent cathetus? Also 1. So tangent of the angle 3 has to be equal to 1, and therefore the angle 3 will be equal to the inverse tangent of 1. Okay, calculate this in the calculator, get me the inverse tangent of 1, and in this case the result is exact, is 45 degrees, and this is an exact value. So we have found this other angle, A3 is equal to 45 degrees. You see? And that's it. That's it. We're done. Why? Because now I can calculate this other angle. How? Well, I have angle 1, which is 63.43 degrees. Let's put it there. 63.43 approximately. We know that this is 45, and therefore we can calculate this angle by the sum of the three angles being equal to 180. So let's get it. That's going to be 71.5 degrees. So theta 1 is equal to 71.5 degrees approximately. And therefore, if that's the measure of this angle, then how much is this other angle? Because remember, the line 1 and the line 2 are making two angles. We have already found one. Okay, this is one of them, and the other, if you notice, the sum of both angles should be 180. Okay, so this angle will be 180 minus 71.5, which is 108. This angle is 108.5 degrees, and so we're done. After all of this long process, we have found that which is the smallest angle. It's clearly this one, 71.5, and that is my answer. My conclusion is L1 and L2 make an angle of 71.5 degrees. This is my conclusion, and that's it. So if you notice, that took us like a long time, a very long time. But you have to understand this. I'm giving the explanations like in very full detail and so on. You can get this done in less than half the time. How much time did that take us? 24 minutes. Yeah, you can get this problem done in about 10 minutes. Okay, the whole thing, and that's how it works, guys. Uh, I was gonna give you another example but I think that's enough. I don't wanna exhaust you with so much time watching videos. We have already 24 minutes. That's enough. Try to use the same method for the other example that I'm gonna give you, or for the examples in the workbook, okay? And in those examples, you're gonna find. Let me erase a little bit of this. We have already completed this problem. This is my answer. Let me erase this part over here. In the other exercises from the workbook that are about getting these types of angles, you may encounter different configurations, okay? Like I told you a moment ago. Maybe your two lines are gonna cross probably over here in this way. This is gonna be line one, this is gonna be line two, but the method is still the same, okay? You need to get these 3 points, this, and this, okay? Get them, cut this triangle in in this way with a perpendicular to the x-axis. You get two triangles formed, and then you're gonna find this angle, and this other angle by the same type of reasoning that I already gave you. Okay, it's the same type of reasoning. It's gonna change a little bit because now your triangle is below, but it's the same idea, the same exact idea. You need to find uh, these cathetas and these cathetas and these cathetas, okay? And then you do something similar, and that's it. That's all you have to do. So I'm gonna keep it right there. Although if you want me to do another example, I can do it. Okay, I'd be glad to do it. So that's it, guys.